Inheritance is a important topic in object-oriented analysis and modeling and design and coding and all that stuff. It's also occasionally a bit controversial. I want you to be aware going in because inheritance is a powerful tool for taking a very complicated system and simplifying it. But it's also easily misused. It's also corrupted, if you will, to solve problems simpler, but maybe make them harder to maintain in the long run. So understanding the proper use of inheritance as a grouping and a distinguishing feature of your model is really essential towards making value of it in the long run of your solutions and code. So where the idea of inheritance comes from is when things are very, very similar, but also kind of distinguished. So if we think of it this way, you have a car, and you know cars, they drive, they go forward, you put your gas in it, does its stuff. So we can actually model that as an internal combustion engine vehicle, ICE, internal combustion engine. And so all cars have VIN numbers and they have colors and they have some sort of amount of horsepower. And internal combustion engines, they have a mile per gallon and you put fuel in the tank. And so if you want to drive one, you tell it to drive, turn the wheel, press the pedals, that sort of stuff. And then you can fill its tank up to keep it going. Now, we might think of it new, but for essentially as long as there's been cars, there's been the idea of an electric vehicle. And so an electric vehicle has some stuff that's very common. If you're going to buy an electric vehicle, it also has a VIN number and it has a color and it has some amount of horsepower, often higher than an internal combustion engine car of its same size. Um, but instead of talking about miles per gallon, we talk about the range of the vehicle, how far it can drive on a single charge, and then you track that charge level instead of the tank level. And similarly, it also drives, but then you charge it instead of filling its tank. So we can see there's a number of attributes that are exactly the same between these two, and there's even some behavior that are essentially the same. You don't drive a internal combustion engine car any different than an electric vehicle car, or a propane or a natural gas bus. Uses the same basic driving mechanism. So the idea is to keep the common things common. And so the way we do that in object-oriented design and analysis is inheritance. So we have this idea of a inheritance hierarchy that we can build up. So a vehicle pulls out all of the common elements of the two different types of vehicles, the electric vehicle and the internal combustion vehicle. And so you can see the VIN, the color, the horsepower, and the ability to drive a vehicle can be put in a class of its own. And then the details that are applicable to an internal combustion vehicle or an electric vehicle can be then further specified in a separate class. So all vehicles, no matter what engine they use, have, colors and they have some sort of horsepower and they drive them, but only internal combustion vehicles then have miles per gallon and a tank level. So if you're selling vehicles on a website, well, all of them have some of the stuff, and then you have other specific things you can pull out. If you want to drive a vehicle, you have a fleet of vehicles you're maintaining. Well, you know what's common, and you know the specifics. What's the charge level of my electric vehicles? So I can go answer those questions. So this relationship in object-oriented analysis and design is typically known as a parent-child relationship or a superclass subclass relationship. So the parent defines these common attributes, these common methods for a whole bunch of objects. You could have a single child, but normally there's a bunch of them. There's a reason to specify it many, many different ways. Where the child or the children, they inherit everything from the parent, all of its methods, all of its attributes, all of it comes down as part of that child's definition, and then that child becomes interchangeable with the parent. So if you are renting a car from an auto rental place at the airport, you can rent a gas car and electric car. It doesn't really matter. You know how to drive them both. You just have to know plug them in and charge them as opposed to getting gas. And then, again, if you're just doing a day trip, it might not make any difference. So that's the goal of inheritance, is to keep common things common and allow the children to specify uniquely. But it's really important, this idea that you inherit everything. So anything you put in that abstract parent vehicle comes into the object of the child. So when I create an internal combustion engine, even though I only see in the UML, the class diagram over here, I only see miles per gallon tank level, the object acquires all of the stuff that comes from the parent vehicle. And when I create an electric vehicle, the object acquires all the stuff that comes from the parent class vehicle. So you can see all the attributes, they show up: VIN, color, and horsepower. They have different values for the different objects that are out there. Obviously, these two cars have different VIN numbers. One's green, one's white, and they each have a different amount of horsepower that's available to them. I mean, in this case, the electric vehicle has lower horsepower because it's a tiny little electric vehicle we're showing. But it is unique values to that based off of both what the child defines, in the class, and also what the parent defines in that class. So when I ask the child to that is an internal combustion engine to drive, I can do that, or I can tell it to fill tank. When the child is the electric vehicle, I can ask it to drive as well, and it can charge the tank. And when I ask it to drive, it does the common behavior that's defined in the parent class. When I ask it to fill the tank or charge, it does the behavior defined in the child class. Now, depending on your programming language, you might have some more details to know about that. So, for example, the type of the variable versus the type of the object. There's could be compilation issues or whatnot. So in Java or C, you have to pay close attention to that. In Python or JavaScript, you don't. You just call what you want to on any object, and it doesn't really matter. But as far as the rules of inheritance goes, you inherit everything from your parent. So the challenge in defining inheritance is really spotting its appropriate use, as I said to start this. Um, Sharing things that are common should be a feature of the model that you're putting forward, not a side effect. And we'll talk about this more as we go through and we get deeper into it. But the reason why the inheritance works so naturally here is because it's a natural relationship. There's a clear relationship between internal combustion vehicles and electric vehicles. They're both vehicles. I wouldn't necessarily say a power plant and that generates electricity and a car has something in common, because a car has an alternator and generates electricity, and so does a coal-fired power plant, right? But that's not a natural relationship. That's just kind of they both kind of sort of do that, but they are fundamentally different. So the rule that might help you define inheritance relationships is the ISA rule. And so the way to apply the ISA rule is to say inheritance is when another class is an example of the original class. So a electric car is a car. A electric bus is a vehicle, as opposed to a power plant is not a vehicle, or a car is not a power plant. Either way. So everything that's true about the parent must also be true about the child. We don't create parents that are just sometimes like their child. There should be all the time like the child. Then that's not to say that the child can't customize the parent's behavior. They can't add to it or modify it in some interesting ways, but they still fundamentally are the same thing. I mean, again, gas vehicles, you have to stop and put fuel in them. Electric vehicles, you stop and charge. But they're fundamentally the same thing to start with. And this relationship sometimes is known as generalization and specialization. Generalization says, what are all these different related objects that are still slightly different, what do they have in common? I'm generalizing to the parent class. Where specialization is the opposite, where I'm saying, okay, given that all of the parent class does this, what are the specialized things that the subclasses do that they do slightly differently? The important thing about modeling, and this is a theme through all of our talks here, is inheritance is always contextual. We can't define a universal model where something is always a child of something else. So for example, we have all these different vehicles that are going on here. The important thing is that they all have the same qualities and not just simply different values. So, for example, if I wanted to create a website to sell vehicles, I could actually just have one vehicle class and I could have an attribute inside of it which says vehicle type and color and miles per gallon and stuff. And instead of having to have a whole different class for trucks and cars and motorcycles and in this case food trucks or whatever, instead of having totally different classes for that, it could just simply be an attribute that's different. You know, instead of a whole class, it's just like, hey, the type of the vehicle is motorcycle as opposed to car. So the important differentiator is that each subclass, if I create a subclass for it, has to add something to the parent class. Additional attributes, more things to store that are not true for all of the classes up above. Again, even like number of wheels doesn't matter. I can have an attribute number of wheels to class, but it should be something unique to that subclass or some additional unique behavior, additional or unique behavior, something that, you know, they all drive, but perhaps they drive differently. A motorcycle, they kind of have to balance that, or put your legs down when you stop or something like that. So there could be something slightly different there that would put the need for the subclass out there. And so this is a very fuzzy concept. I can't give you a hard and fast rule because it's, as I said, contextual. But the important thing to remember is that the value of inheritance here is I want to keep common things common. Don't create additional classes unless you are, you know, finding new code that doesn't apply to everybody else. But at the same time, don't reuse things just simply to reduce the amount of code you have. If it's not truly common, then don't make it common. There's actually other strategies to help with that we'll talk about as we go. The network of objects you're trying to define here ideally should be interchangeable. That at any point, if I have any of the subclasses of an inheritance hierarchy, it can behave exactly like the concept that is the parent class, and nothing should vary. Again, like a motorcycle might be pushing it. You don't rent motorcycles at the airport because not everybody can drive a motorcycle. You don't have a license for that. So a motorcycle might not be appropriate in certain inheritance hierarchies, and in others it makes perfect sense. But it has to be entirely interchangeable for that parent. Yet these inheritance hierarchies still allow you to customize the children. There's no value in an inheritance hierarchy if I can't add value, add variables, add attributes, or change the behavior when needed for that child. And so the most important thing to remember is the is a rule. So ask yourself, in this context, for this application, if the child class you're proposing is a representative of that parent class and always is a representative of the parent class, then it's very, very appropriate for that to be inheritance. So again, this is an introduction. There's a lot of refinement that we'll need to go through as we talk about this. So keep working through these videos, and keep looking for examples, and you'll get a much better feel for the value and the appropriate use of inheritance.